Today's lesson is all about determining proportionality. We're going to be given situations, either verbal situations or real life problems, and we've got to think, hey, is this relationship proportional or not? Meaning, are these going to be related in somewhat of a, not an equal way, but proportional, meaning like that black bean recipe where, hey, we're increasing the units, the ingredients, but we're changing them all at the same rate so that the taste is going to be the same. I'm not going to have too many beans in my soup or too many tomatoes. It's going to be at the same proportion, so it's the same type of soup. All right, so the vocabulary words for this lesson would be equivalent ratios. Equivalent ratios are ratios that name the same comparison. Remember, we talked about ratios being a fancy schmancy fraction. Equivalent ratios would just be equivalent fractions. A proportion is an equation that is basically two ratios are equivalent to each other. So it's a fraction equal to another fraction. The new one here would be constant of proportionality, and this is huge. Constant of proportionality, it's this number. It's a constant value of the ratio of the two proportional quantities. Unit rate, we've talked about this before, unit rate is the same thing as constant of proportionality. What this means is that if you're changing the values, if you're changing your quantities, if it's proportional, it's always going to change by the same amount. It's always going to change by a constant, meaning the same amount. That constant would be the constant of proportionality or the unit rate or unit price. This is a big concept here that I want to make sure you understand. Let's look at what this will do for example 1. In example 1, we have Mrs. Cochran is planning an end-of-the-year pizza party for her students. Ace Pizza offers free delivery and charges $8 for each medium pizza. This is an important piece of information. We're going to complete the table to determine the cost for different numbers of pizzas ordered. So I have pizzas ordered and I have cost. When we have a table like this, pizzas will be my X and cost will be my Y. It's just helpful to label those numbers out by the side. The cost that we pay depends on how many pizzas we order. So Y would be my dependent variable, depends on how many pizzas are ordered, and X is independent. It doesn't matter how much money you have. It only matters about the number of pizzas you order. So that's the independent. Okay, so if I know that it costs $8 for each medium pizza, I am going to rock out some multiplication here, and I know that I'm going to take however many pizzas I order and multiply them by 8. So if I ordered 2 pizzas, I'm going to be I'm going to be paying $16. 3 pizzas, I'll pay $24, and 4 pizzas, I'm going to pay $32. Let's move on to number B, or letter B. For each number of pizzas, write the relationship of the cost and numbers of pizzas as a ratio in simple form. What do you notice? So this is our Y divided by X. This is kind of a big deal over here. Y divided by X is what they asked us to do. This would be our cost in words divided by pizzas. Let's just check it out for each one of those columns of our table. So I'm going to start with the first one where we had $8 for 1 pizza. So $8 for 1 pizza. And the second one would be $16 for 2 pizzas, which simplifies to $8 for 1 pizza. Then the third one was $24 for 3 pizzas. If we simplify that, we get $8 for 1 pizza. And lastly, I want you to take a wild guess. What do you think it's going to be? It is $8 for 1 pizza. Coincidence? I think not. Okay, this is important here. They're all the same. My my cost will always be $8 for one pizza. No matter how many pizzas I order, I'm just going to take that amount of pizzas ordered and multiply it by 32. This right here, this $8 for one pizza, we've called this the unit price before. The unit price or the unit rate is $8 for one pizza. Our new vocabulary word for it would be constant of proportionality. Because all of those columns, all of those ratios of cost of pizza were the same thing, that means that this is a proportional relationship. If we think backwards, if I ordered 0 pizzas, am I going to pay any money? No, it would be $0. Other ways you can think about it too, if you look at your table, for every pizza, for every one pizza I go up, my table is increasing by $8. So for every change in X being 1, it goes up by 1, up by 1, up by 1, up by 1, my Y or my cost increased by 8. So just other ways to think about it too. Let's go ahead and graph this graph and see what happens. We're going to take the table and the information here. Remember, we want to label, so this would be number of pizzas. And I don't think it's going to let me, right under there. So just number of pizzas is for my x-axis. And my y-axis, we're going to label it cost. And that's going to be in money. Sorry, that's a really bad dollar bill. Now that I have my units labeled, I'm going to go ahead and add in my numbers here. So I have, from my table, I need to go cost from $8 to $32. So it makes sense for me to go up by $5 increments for each one of these lines, which means I got to be sorry, I paused there. I've got to be really careful about how I plot these points. I hope that yours will be more accurate than mine since I'm drawing on an iPad. I'm going to go ahead and add these little tick marks here to help me out. 1, 2, 3, 4. 1, 2, 3, 4. Go ahead and do that on your paper too. And then 1, 2, 3, 4. So that will show increments of 5. Remember, we graph our ordered pairs will be x comma y, so that 1, 8 will be 1 comma 8, then 2 comma 16, 3 comma 24. I'm just pulling off those tables. 4 comma 32. So since it's x and y, I look at this is my x coordinate. It's going to follow along with this x label. So for 4 pizzas, it costs me $32. I'm going to graph 1 comma 8. So 1, go over 1, up 8 will be here about. 2 comma 16 will be about here. 3 comma 24 be over here. 4 comma 32 will be up here. And then if we think about 0, 0, it'll be there. If I don't pay any money, if I don't order pizzas. If you look at this line is a straight line going through the origin. It's a proportional graph. What we've done here is we've taken a look at how to determine whether or not a relationship is proportional from my table. If I look at my table and I pull all of those y divided by x's, they're all the same. That's my constant of proportionality. Now here on a graph, I know that my relationship is proportional when I have a straight line that goes through the origin. This is very important. So on my table, if I take my y's divided by my x's and I get the same ratio every time, My table shows a proportional relationship because it's always increasing by the same amount. And then my graph is a straight line through the origin, so that also shows a proportional relationship. Let's look at example 2 pretty quickly. We're going to look at Uptown Pizza selling medium pizzas for $7 each, but this time they charge a $3 delivery fee per order. Is the cost of an order proportional to the number of pizzas ordered? Let's look at our table. All right, so if I order 1 pizza, I've got to pay the $7 plus I add in that $3 delivery fee. So the $10 comes from the 7 plus the 3. Now if I order 2 pizzas, then I've got to pay $7 each, so that's 2 times 7, which is 14, plus the $3 delivery fee, which would make that 17. Then for 3 times 7 plus 3 times 7 is 21. Add my 3 is 24. And then 4 times 7 is 28 plus 3 is 31. That's all my costs here. Now if you look, from side to side, I'm going up by 1 pizza and then I'm changing 10 plus 7 is 17, plus 7 is 24, plus 7 is 31. So I'm kind of increasing by the same amount when we look at it at our table going this way. But let's look at what happens with our table. So if we look at our table and we're doing those y divided by x, that's important. Y divided by x, so in this case our cost per pizza, which is just our unit price, is what we want to find out. For this first column here, it would be $10 for 1 pizza. For the second column, $17 for 2 pizzas means that it would cost us $8.50 for 1 pizza. For the third column, we have $24 for 3 pizzas. Simplify that to find our unit price. And I get $8 for 1 pizza. And then lastly, if I take my $31 for 4 pizzas and divide that out, then it would be something different. I mean, it would be, I can't do this in my head. It would be $7.50, I think, for 1 pizza. Okay, that's big difference there. If you look at our unit prices, our constant of proportionality, we're not paying the same amount for every pizza. That's not okay. That's not right. So that, because of the $3 delivery fee, that messes everything up. If it were just $7 each, but no $3 delivery fee, then you would have a proportional relationship. But now that delivery fee messes everything up, and it's $7.75. Sorry about that. This one, $7.75. It messes everything up. It's not proportional anymore. Okay, let's take a peek at the graph and see what happens. Okay, first things first. I've labeled my axes. X is pizza, and then Y is cost. I know I need to go from 0 to 31 based on my table here, that on my y-axis. So I'm going to go ahead and do my 5, 10, 15, 20, 25, 30. We can do our 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Hope yours are more accurate than mine. I'm trying to go fast for you. Okay. So pulling off my points from the table, I would have 1, 10, 2, 17, 3, 24, and 4, 31. Plot my points. So 1 pizza is going to cost me $10. 2 is going to cost me about 17. 3 cost me $24. 4 cost me $31. And let's think back to 0 pizzas. I got to pay that delivery fee if I call them in. So if I do, looking at the table, if I'm going backwards on my table, so I'm going down by 1, down by 1, down by 1, 1 minus 1 would be 0. Let's follow along here. I'm going down by 7, down by 7, down by 7. So 10 minus 7 would be 3. So I still got to pay that $3 delivery fee. It means I'm going to have a point right here. If I graph that line, I'm going to notice that it is a straight line. That's good. But it does not go through the origin. Those are the two pieces of information that have to be true about a proportional relationship, a graph. It has to be a straight line, so we got that, but it does not go through the origin. This is not proportional. And we knew that it wasn't proportional when we looked at our table because our unit price, our constant of proportionality, was not the same. And we just proved it again by looking at our graph. That does it. Remember, in a table, take your y divided by x, find that constant of proportionality, or what we call the unit price. If those are the same for each column in your table, then you know you have a proportional relationship. Then looking at your graph, if you have a straight line going through the origin, then you also know that it's proportional.